factors all do the trick. They undo work like magic. I know you're looking for this, so they're not in your way. Multiply, divide, square root, square both sides. Base 10, take a log. 10 and take the arc, baby. Hey, operations, they might be crazy, but use it in this and solve me, maybe. It's hard to solve that without you, baby. But use it in this and solve me, maybe.
Well, welcome back, Algebra 1 students. Here we are. We're going to solve some equations today with polynomials. Solving polynomial equations in factored form is what we're talking about in 7.4 on the Big Ideas curriculum. And what we're learning here in this lesson was we're learning a new property called the zero product property. We're also going to learn a little bit about factoring polynomials using a GCF. That would stand for greatest common factor. And so let's jump right in. Here's our cartoon of the day, a little Far Side cartoon. Bummer of a birthmark, Hal. There's a deer with a bullseye right on his chest. Oh man, that would be a bummer of a birthmark for a deer. All right, let's move on to looking at factored form. So it says solving equations in factored form. What is factored form? So what I got here is three different forms shown. One's factored form, standard form, and the non-standard form. So the standard form we should be familiar with. This is where it's all in descending order. We've been doing this now since the first section in 7 here, and just getting things in descending order. Here's a non-factored form where it's kind of on both sides. So when you actually have an equation here, it's in standard form when it's equal to 0. That's one thing you want to see there. It's not in standard form like this when it's not equal to 0. Factored form would be when you have it in factors here with two binomials multiplying each other. Now that looks like when we were multiplying binomials with FOIL or a double distributive property technique. So that's our factored form. So we've been already seeing this kind of form where we have two binomials next to each other. And it could look like this, or it could be a monomial times a binomial or something like that. This is two factors. These are two factors of a standard form equation. So we could factor these trinomials here, these are all trinomials, into these two binomials. That's what we could do. So this is the form we're going to see today. We need to have it in this form in order to be able to solve it in factored form. So there on page 221 in your notes, here again is showing standard form and factored form. So it says factored form is when it is written as a product of factors. So you can write that down for that vocabulary. A product of factors, so this is standard form, just the binomial. Here's a trinomial. Factored form would be a product of the factors where you're multiplying the x, the monomial, times the x plus 2. That's a product of factors. Or the x, these two binomials are factors and you're multiplying them, so it's a product of two factors of this. If I was to distribute the x back into here, I'm going to get the x squared plus 2x. If I was to multiply these two binomials like we did just a little bit ago on the last couple lessons, we're going to end up with this trinomial here. Now we're looking at this new thing called the zero product property. So once we get it into factored form, they're going to be set up in factored form at the beginning for us, we need to use this zero product property. And so you can see what it says here. It says the solutions. So basically, what is the zero product property? It's basically where you set each factor equal to 0. You want to write that down either in the vocabulary or you can write it down in this core concept. And you can see here the example of it. Here's your a, b is equal to 0. If that's your equation, we're going to set each factor. A is a factor and b is a factor because it's a product right there, a times b. So a equals 0 and b equals 0. So basically what you're going to do, you're going to break apart the two factors, like up here. Here's our two factors. You say x equals 0, x plus 2 equals 0. Or these two factors, x minus 3 equals 0, x plus 8 equals 0. So that's what zero product properties does. It sets each factor equal to 0. Now you might just have two factors. You might even have three factors or four factors. It doesn't matter how many factors you have, but you're going to set each one equal to 0. And it says right here, roots. What is roots? Roots would be the solutions of a polynomial equation. You want to write that down for roots on your vocabulary. Roots is just another way of saying the solutions, the answers to a polynomial equation. So you might hear that, read that sometimes, or hear me say that sometimes. All right, let's move on into looking at just our first extra practice right here on page 222. So we have equations, and they're in factored form. They're all in factored form right now. Set equal to 0. Okay, so factored form is always going to be set equal to 0. We saw that before. When it wasn't set equal to 0, it wasn't in factored form. That was non-standard form, in fact. And so we need to always get them set equal to 0 to be able to be in factored form. And then we're going to use our zero product property. So here we go with number 1. So the zero product property would say this. I'm going to set x equal to 0 and the x plus 5 equal to 0. And now x equals 0 is already an answer. So one of the answers for x is just 0. But now for this, we'd want to just subtract 5 and get x equals -5. So you just solve what you have left. You might have a 1 or a 2-step equation still to solve if you have a binomial here. So our answer for this is x equals 0 and x is equal to -5. There's 2 answers, one from each factor. Because there are 2 x's in this problem, if we were to multiply it and do the distributive property, we're going to see x squared, and that would tell us there's going to be 2 possible answers because you have x squared. If it's an x to the 3rd power, you'd have 3 possible answers, and so on. All right, let's take a look at number 4. Here's 2 binomials on this one, c minus 2, c plus 1. So zero product property will first set each factor equal to 0. C minus 2 is equal to 0, and c plus 1 would be equal to 0. I usually draw a line kind of just between those two, kind of 2 separate equations. And then for this one, you'd have to add 2 to both sides, and for this one, you'd have to subtract 1 from both sides. So our answer for this is going to be c is equal to a positive 2, and c is equal to a -1. That's where we're going to get our answers for these. So for 2 and 3, go ahead and pause the video and try doing 2 and 3. That's just like number 1. Do use your zero product property to get the 2 answers. And then just play to check those 2 answers. All right, so hopefully you have answers for 2 and 3. So your zero product property should look like this. Set a equals 0, set a minus 12 to equal 0, and then just add 12 to both sides. Cancels there. So answers will be a is equal to 0 and a is equal to 12. 0 and 12 are the 2 answers. Number 3, 5p will equal 0 and the p minus 2 will equal 0. If you divide by 5 here to undo the 5 times p, 0 divided by 5 would still be 0. In this one, you're just going to add 2. So your answer is going to be p is equal to 0 and p is equal to 2. So if ever you have a monomial like this right here, no matter what is here, no matter even if it says a p squared, in fact, if that was what was there, it's still going to be 0, no matter what that is. If it's a monomial, your answer there will be 0. If it's a binomial, you're going to have something in there as a number. All right, let's move on to looking at this next part there on 221 back on your vocabulary. Another vocabulary word is repeated roots. So remember, the roots word just means solutions. So we're talking about repeated solutions. Solutions that are the same number but more than once. So if we were to look right here, no, you don't need to write these examples down, but what you do want to write is for repeated roots. Write this down for the vocabulary. It's when 2 or more roots or solutions of an equation are the same number. So on A is going to have different roots. So this one's they're close, but they are still different. -7/2 and a +7/2 when you are using the zero product property and solving. But for B, it says x minus 1 squared. You have a binomial squared. So we're only going to get just one answer for that because basically that means there's 2 of exactly the same binomial. And so you're going to get 1 twice. You know, you're going to x equals 1 and x equals 1. You don't need to say it twice. You just need to say the answer really just once. So the equation has repeated roots of just x equals 1. And so that's what a repeated root is. This one you can see there's 3 binomials. You're just going to set, even if there's 3 factors, you're just going to set each factor equal to 0. Each one gets set equal to 0 and you're solving each one. You'd end up getting 3 answers for x. All right, let's take a look at some more extra practice here on page 222, number 5 and 6. I'll go through these 2 and then you guys can try 7 through 9 on your own. So for number 5, we're first going to use the zero product property. Again, notice they all say equal 0, so we're set up ready to just use that zero product property. Again, if it's not in standard form, as we saw there at the very beginning, you would have to first adjust your equations so that they would be in standard form. So for number 5, we're using our zero property, set each factor equal to 0. 2b minus 6 is equal to 0. 3b plus 18 is equal to 0. So as I solve this one, it's a two-step equation to solve. I'm going to first add the 6, then divide by 2. So add 6 and get 2b equals 6, divide by 2. And so that's going to end up giving me a 3 here for the first answer. B is equal to 3 for this one. And then over here, again, two steps. First subtract 18 and then divide by 3. So when I subtract 18, 3b is equal to negative 18. Divide by 3. Negative 18 divided by 3 would give me a negative 6. So b is equal to negative 6. So there's my two answers here for number 5. If we look at number 6, again, setting each factor equal to 0 separately. So 3 minus 5s equals 0. Negative 3 plus 5s equals 0. So on this one, as we solve, this one I might want to add the 5s to both sides and then divide by 5. So I do that, add 5s. So now I have a positive 5s over here, and then divide by 5. That gives me 3/5. So I'm getting 3/5 as an answer. And as I do this one I might want to add 3 to both sides, and I got 5s equals 3, and I divide by 5. I'm also getting 3/5. So I get 3/5 on both of these answers. So what we could say is we have a repeated root of s equals 3/5. So you don't need to say 3/5 twice. You can just say it once, but you just want to say that it's a repeated root. All right, go ahead and pause the video and then try 7 through 9 on your own, and then just play to check your answers for 7 through 9. All right, so hopefully you have an answer here for 7. You can see this one's definitely going to have repeated roots because it has a binomial square. Whenever we have that, there's more than one of these, so it's there twice. So we really only need to solve it just once. So if you just solve one time, you just know your answer is going to say it's a repeated root of x equals 3. That's what we're going to see for an answer. So when you add 3, you get x equals 3, but you're really 2 of them, so that's why you want to say repeated root. Number 8, set each factor. Now these are going to be different answers. They're different binomials. So the first one here, you're going to say 3d plus 7 is equal to 0. If I subtract 7 from both sides, I get 3d is equal to negative 7. And then divide by 3. I'm going to get a negative 3/7 as an answer for this first one. And then for the other one over here, we're going to see first 5d minus 6 is equal to 0. That's the zero product property part. And then add 6 to solve it, and then just divide by 5 to finish it off. So 6/5 is our answer on that one. So d is equal to a negative 7/3 and a positive 6/5. You can just leave these as improper fractions. That's okay to do. For number 9, these ones are very similar. They're just going to be different signs. So you're going to have the same number answer, but they're just going to be one's positive and one's going to be negative. So for this one, 2t plus 8, that will equal 0. Subtract 8 and divide by 2. We're going to get a negative 4 for the one on the left. On this one, you're going to do 2t minus 8 equals 0. Add 8 to both sides. 2t equals 8 and divide by 2. We're getting positive 4. So we're getting t equals negative 4 and t is equal to positive 4 for number 9. All right, let's keep moving on. Number 10 through 12. So now we're looking at some that have maybe more than 2 factors. So on number 10, you could see w plus 4. There's 2 of those. So we're definitely going to have a repeating root from this one. And then there's going to be also a w minus 1. So set each of these factors equal to 0. So our first one here, you're going to get just w plus 4, subtract 4. So w is equal to negative 4, but that's going to be a repeated root for that one. So you'd want to say that for the negative 4, repeated root of a negative 4. This one, w plus 1, is also equal to 0, and then subtract 1. So w is also equal to negative 1. So there's your 2 answers, negative 4, negative 1, but you want to realize that negative 4 has a repeated root. Let's look at number 12, and then I'll have you try number 11 on your own. So each factor here is going to get set equal to 0 separately. So 4 minus m equals 0. And this one I might want to add m to both sides. So m is just equal to positive 4. For this one, 8 plus 2/3 m is equal to 0. And so as I do this one, I might want to subtract 8 first to get the 2/3 m by itself. And then what you need to do to get rid of the 2/3, you could multiply by the denominator, multiply by 3, then divide by 2, or you could multiply by the reciprocal of this fraction. That would do it in one step. If I multiply by 3 over 2 to both sides, that will undo this 2/3, leaving me with m on the left, and then negative 8 times 3 over 2. So that's what I'm going to show you here. M is equal to negative 8 times 3 over 2. And so that's like 24 divided by 2, that's 12. And it's a negative because negative times positive will be a negative number. So far we got m equals 4. We have m equals negative 12. We're going to get one more answer on this one. Negative 2 minus 3m, that's going to also equal 0. And so I could add 2 to both sides. Now I have negative 3m is equal to 2. Divide by 3. So our answer is going to be a fraction on this one when I divide by 3. That's a negative 2/3. So m is equal to negative 2/3. So there's our 3 answers. So I just circled them separately like that. All right, so go ahead and pause your video and then do number 11. See if you can get that one correct, and then play it to check your answer. All right, so the first one, you have a monomial out here. That's definitely going to be 0. No matter what that says, if it's a monomial, it'll always be 0 for the variable. G is equal to 0. And now on this one, you're going to have basically one positive, one negative of the same thing. So this one, you can add 3g, divide by 3, so you're getting positive 2. So g is equal to positive 2. This one should be a negative 2 because it's the same kind of thing, just an opposite sign. So if you subtract 6 from both sides and divide by 3, negative 6 divided by 3, that also gives you a negative 2. So 3 answers here, 0, positive 2, negative 2 is for G. All right, let's move on. We'll pause here real quick for a little quick joke of the day. So the joke is, what do you call a girl with a frog on her head? What do you call a girl with a frog on her head? Well, it kind of sounds a little strange. You would call her Lily. She would name her Lily. Because frogs are usually sitting on a lily pad. So that must mean her head's a lily pad. Or she's using her head as a lily pad. I don't know. All right, moving on to our next part here. We're going to now look at the greatest common factor. So we're looking for a greatest common monomial factor from two terms here, and so we're looking for number and the letter. So both number and letter is what we're looking for. So on this one, you could see for number 4, it goes into 24, so you could factor out a 4. So you're going to factor out what can go into both of these. 4 obviously goes into itself, 4 can go into 24 6 times. And then for the variables, you're going to look at how many x's could you pull out for your monomial factor. So far we got a 4 in that monomial factor, but you can pull out 3 of them because you have 4 x's here, 3 x's here. You can pull out the smaller node. So it's going to be 4x to the third is what you're going to pull out. And so now you have 4x to the third, and then you're going to have your x plus 6, what's left over. What's left over from the first term as you pull out a 4x to the third is 1x left. What's left from the 24x to the third is just a 6. And so that's what we're seeing. All right, so let's go ahead and try a couple of these here. So on page 223, it says factor the polynomial. We're going to factor out a greatest common factor. So the first part here, I'll do these two, and you can end up doing these 4 over here. So for 13, we want a GCF number. What's the GCF number going to be? Just looking at the two numbers, 6 and 3. So smaller number is 3, so it can never be the bigger number. It's going to be the smaller number or something even smaller than that. So since 3 can go into 6, we can factor out and pull out the 3. So GCF number is 3. And now GCF variable, that would be the letters. Between these two, we can pull out 1x, only 1x. This one only has 1 to give. So that means your GCF variable would be x. So if you combine those together, 3 and x, your GCF will be 3x. That's what we're going to pull out. Put that on the outside of a parenthesis. And then what would be left from each of these two terms? So from the first term, if I divide basically each one of these by a 3x, 6 divided by 3 is still 2, and there's 1x left. And then if you divide 3x by itself, there's just a 1 left. So it's plus 1. So if you factor out the whole thing, you have to still put a 1 there, because you need to realize that what we're doing, basically factoring, is the opposite of multiplying. We can always check to see if we got this right. If we multiply it back in by the distributive property here, 3x times 2x would give me my 6x squared. 3x times the 1 is the 3x. And we know we're correct. We know we did that correctly. As long as there's no more GCF parts between these two. There's nothing else in common between those two terms. All right, coming to 16. As far as the GCF number, there is no number really. 7 and 2, there's nothing you can pull out. So your GCF number is just going to be 1. So if there really isn't anything, obviously 2 doesn't go into 7, so you can't pull out a 2. There's nothing that can go into both 2 and 7 except the number 1. And so we're left with just a 1 for the GCF number. For the GCF letter, we have 7 z's in this one, z to the 7th, z to the 6th. So the smaller number of z's would be 6 of them. So you could say z to the 6th right there is your GCF variable. So to put these two together, 1 times this will just be 1z to the 6th or z to the 6th. So our GCF that's going to come out is the z to the 6th. That's going to be outside the parenthesis. What will be left in here will be the 7 and the z, because there's still 1 z left. As you took only 6 out, there's still 1 left there. And if you multiply this back, you'll get this term. And on this one, you took all the z's out, but you're left with the 2 still there. And if you multiply z to the 6th times the 2, you're going to get 2z to the 6th. All right, so go ahead and pause your video. Try factoring 14, 15, 17, and 18. And then play to see if you're correct. All right, so hopefully you've got these 4 done here that I've hidden in green. And you're just checking your answer now. So for number 4, what you'd want to pull out, you want to see 4 can go into 20. So you're going to pull out 4 for the number. And then the smaller number of y's, there's 3 of them. So y to the 3rd. So 4y to the 3rd should be outside the parenthesis. What's left would be y minus 5 on the inside of the parenthesis. Now, you got to remember, there's 2 terms here. There's still going to be 2 terms in the parenthesis. You would never want that to be different. You wouldn't want to go from 2 terms to 1 term in the parenthesis. So in the parentheses, it's always going to be the same amount of terms you have in your problem. And number 15, for the number, we can say 6 does go into 18, so you can pull out the 6, and there's 1 u here, so you're going to have to say 6u. 6u comes out, and what's left is 3u to the 3rd power minus a 1. So 18 divided by 6 is 3. If you take 1u away, it's still just 3 there, u to the 3rd. This one, we took those 6u completely out, so 6u divided by 6u is still a 1 there, so minus 1. Number 17, 8 does go into 24. So you can pull out the 8. And there's 1 h in this one, so you can only pull out an 8h. So you're going to still be left, 24 divided by 8 is 3. And you took out 1 from these 3 here, so there's still 2 h's left in this term. 3h squared. You took out this whole thing. 8h divided by itself is just a 1. So plus the 1. Number 18, 15 does go into 45. So we can pull out 15, and between the f's, there's just 1 f on this one that can come out. So 15f is what's going to be on the outside. That's what you're factoring out. That's your GCF factor. And then there's still f to the 3rd, because you took the whole 15 out. And there's still 3 f's left from the f to the 4th. 45 divided by 15 is a 3. You took the f away, but it's just a minus 3 there at the end. All right, so if you didn't get those correct, just go ahead and fix that on your paper. Hopefully you understand maybe what you did and that you can do them. We're going to get some more practice on the next problems because we're going to have to still factor these next ones as well. So let's go on to number 19. We're going to see on number 19 now, solve the equation. So now we're going to put the factoring with the zero product property. So the first thing we're going to have to do is factor to get into 2 factors, and then use that zero product property to get our answers for the variables. So for number 19, we got to factor the GCF out of this. So in this case, it's just going to be a k. Okay, there's a 1 in front of k, so it's just going to be k only to come out. So that's the first thing, factor GCF. K comes out. What's left here is a 6k, because you just took 1k out, you factored the 1k out. K divided by K is 1 here, so plus 1. So there's your two factors. Now we use the zero product property from here. So zero product property, set K equal to 0, set 6K plus 1 equal to 0. And the last thing now to do will be to solve here. So on this, you're going to just subtract 1 from both sides. Once you subtract 1, you're going to get 6K is equal to negative 1. So as we solve, we've already pretty much got K equals 0. That's done for us. You subtracted 1, now you have 6K equals negative 1 and divide by 6. You end up with a fraction there for the other answer, negative 1/6. Alright, so I'm going to have you try number 20 and 21. Go ahead and pause the video. 20 and 21 are just like number 19. So start with factoring the GCF from this one, and then use zero product property to set each one equal to 0, and then solve from there to get your answers. So do 20 and 21, and then go ahead and play it again to check those answers. Alright, so if we have answers for 20 and 21, first factoring out GCF for number 20, from 35, 35 obviously does not go into 49. 35 is a smaller number, but it doesn't go into 49. So there is a number, 7 does go into 35 and 7 goes into 49. That's what you want to factor out is a 7. And there's one n to factor out. That's the smaller number of n's. So 7n is on the outside. 35 divided by 7 is 5, and it's just a 5 because you factor out the n. Minus, bring down the minus sign, 49 divided by 7 is 7, and you factored one n out, so there's still one n left in there. And then zero product property, 7n is going to be set equal to 0. And so since that's the monomial, n is just going to equal 0. Again, always when you have a monomial equal to 0, your variable will just equal 0. Binomials, though, you have to really solve those ones. So 5 minus 7n, you're going to just be, maybe I would probably bring the 7n this way since it's negative to make it positive, add 7n. So now 7n is equal to the 5 divided by 7 that's in front of n. So 5/7 is your answer for n as well. 0 and a 5/7. For 21, 4 does go into 52 13 times, and you can factor out one z for the variable. So a 4 and a z. So that's what you're getting there, 4z, and then z from the first one plus 13, or I said 52 divided by 4 is 13. And so again, your monomial, 4z equals 0, your answer is going to be 0 for that one. Z plus 13 equals 0, just subtract and get negative 13. So your two answers, 0 and a negative 13 for 21. Now 22, the difference between these three is that they're not in standard form. So 19 to 21 were all in standard form because they were equal to 0. That's standard form. These ones are not standard form, so we're going to first have to adjust them so that we put them in standard form. So that's the first thing to do here. Standard form. To get standard form, set it equal to 0, which means I'm going to add 72x to bring it over to this side. So as I add 72x, I'm now going to have 6x squared plus 72x equal to 0, because those will cancel. Now there's standard form. Now that we have it in standard form, we now can factor out the GCF here. Okay, so we're always going to try looking for a GCF first on any factoring we do. In factoring, we're going to start to learn how to do more factoring in lessons to come. But you always start by looking for a common factor, a GCF. And so 6 does go into 72. You can factor out a 6. You can also take 1x out. So 6x is going to be on the outside. There's still going to be an x plus 12 left here from these two terms. So the 6 goes outside. There's only 1x coming out, so 1x is left for that first term. 72 divided by 6 is 12, and you took the x out of that. So again, you can always check your factoring by multiplying back in to see that you got that correct, and if there's no more common factors between these two terms that are in the parenthesis. From here, you're going to do the zero product property. So again, 6x equal to 0, and the x plus 12 equals to 0. So this one obviously is 0 because it's a monomial, so x is equal to 0 there. Subtract 12 and you're getting negative 12 as well. So 0 and negative 12 is our answer for 22. Alright, so go ahead and pause your video, do 23 and 24. Start with putting in standard form, and then go through zero product property, or actually factoring, then zero product property, and then solving. So do 23, 24, and then play it to check those two answers. All right, so if we have answers for 23 and 24, you just follow this process I was just doing on 22, starting with setting it in standard form. So I'm going to, since the s is here, now you may have subtracted 11s squared. I would want to probably keep this positive, keep the higher exponent positive, so I probably would have subtracted 22s, brought that over. So now it will say 11s squared minus a 22s is equal to 0. That's probably the better way. So that way you keep your first term in the standard form here. It's probably best to do that. I think it's easier. You could still get it correct if you did it the other way as well. So it doesn't mean you got it wrong or anything. It just means you might have had a more challenging time with the signs as you solved. So now as we factor this, 11 does go into 22. So we're going to factor out an 11s. 11s comes out. So there's still going to be an s minus 2 left from these two terms. So you take the 11s, take one s out. There's only one s left from that first one. Then 22 divided by 11 is 2. So in the monomial, that's going to equal 0. S is equal to 0 for that one when you set that one equal to 0. S minus 2 equals 0 from 0 property. And then you get positive 2 because you're going to add 2 to both sides. So 0 and 2 is your answer for 23. For 24, this one, I'd probably move the 21p this way. So subtract 21p to first get it in standard form. So 7p squared minus 21p is equal to 0. There's our standard form. 7 does go into 21 3 times. We're going to factor out a 7 and a p. So just 7p comes out. And there's still a p minus 3 left. And so then you set each factor equal to 0. So your monomial, 7p is equal to 0. P equals 0 for that one. P minus 3, add 3, so P equals positive 3 for that one. So 0 and positive 3 is what your answers are for 24. All right, we just have one last problem. Let's take a look at our last one here, number 25. This is kind of more of a real-life situation problem. Take a look at this. Now, we're talking about a boy kicking a ball in the air. So if I show you a picture of this here, it's kind of what it's going to look like. If he kicks the ball in the air, it's going to look like that kind of a shape. So he's going to kick it from here, it's going to go up, and it's going to come down and come back to the ground. Hopefully you kind of keep that visual in your mind as we read through this problem. So the boy kicks the ball in the air. The height, y, in feet above the ground of the ball is modeled by this equation. Y equals negative 16x squared plus 80x. Where x is the time in seconds since the ball was kicked. So find the roots of the equation when y equals 0. Explain what the roots mean in this situation. Remember, the word roots, we learned that is just another way of saying solutions. So what are the answers for x when y equals 0? We're going to substitute the y with 0. We're going to plug 0 in here. That's going to give us our standard form. So we'll do that first. So we're going to say, okay, 0 is y is equal to this negative 16x squared plus 80x. Okay, so that way we'd want to solve for x, just like we've done before. Now we have a standard, it's in standard form. We just got to factor out. So 16 does go into 80. So what we can do there is I would factor out a negative 16x. Since the x squared here is a negative, we want to factor out the negative. We don't want this term to be negative. We want the one in the binomial here to be positive first. And 80 divided by 16 is 5. It's also going to change the sign. So again, you can double check by doing negative 16x times x, giving you this term. Negative 16x times negative 5 will give you a positive 80x. And then you just set each factor equal to 0 as 0 product property like we've done. So the monomial, this one will equal 0. This x plus 5 will equal positive 5. So there's your two answers for x. So that's what we did. We did find the answers. Just find the roots. We found the roots. The roots are x, are 0 and 5 for x. But now the next part says explain what the roots mean in this situation. Okay, so remember the x refers to the time, it's in seconds, since the ball was kicked. Okay, so now we have two times here, 0. So this would be 0 seconds, 5 seconds. That's what that's representing. So basically we're seeing that this right here, the x, is the ball kicked at x equals 0 seconds. Okay, so the ball is kicked at x equals 0 seconds. 0 seconds obviously means that's we're at the very beginning. So if you was going to kick the ball and you're going to use a stopwatch and time it, you would kick it and then you would start it. That's at 0. And then this one, x equals 5, is the ball hits the ground at x equals 5 seconds. So you're timing it. How much time is the ball in the air? So it starts at 0 seconds when he kicks it, and then when it hits the ground, you stop your stopwatch, and that says 5 seconds. So the best way, I think, maybe to explain it here would be from the time the boy kicked the ball to the time it came back to the ground is 0 to 5 seconds. From 0 seconds to 5 seconds, it took 5 seconds. The ball was basically in the air for 5 seconds. All right, so that concludes our lesson here on 7.4, was solving these equations in factored form. All right, well, I'll see you on the next lesson. We're going to talk more about factoring for the rest of this chapter. You guys have a great rest of your day.